My name is Katerine Velasquez, and I'm answering part 3 of worksheet number 5. Here is my circuit and my code. This is location 1. So it's going 180, stopping at the brightest spot, and then going back home. Here it's doing the same thing. Second location, and then going back. Then here. And then in the code, we are starting off by setting up the steps for revolution, which is going to have the number of steps to complete in the turn for the motor. For the stepper motor, we are setting up our button pin as well as the button state, as well as the button pin for the photoresistor, as well as a variable for the photoresistor value. We have a variable for the step count, and then we have variables for the brightest light reading, and then also for the brightest light angle, or like the step within the 180 revolution. Then we are setting up or initializing the stepper library through the pins. In the void loop, we are setting up the speed of the motor as well as the serial port for the debugging. And then we are calling and setting up the pin for the button as well as for the photoresistor readings. In the void loop, we are reinitializing the button state, the step count, and the bright light reading, so we are printing out the correct values. Then we read the button state using the digital read command, and here we have if button is pressed, therefore we are going to print button pushed, and it's going to go through the while loop and command the stepper to go forward through increments. Here we have a step count where we are doing an increment of 1. Then we have a comparison where photoresistor value, or we're taking in the photoresistor value and reading it. Then we have a conditional where it says that if photoresistor value is greater than the bright light reading, we are going to overwrite that variable, so that bright light reading is actually now the new variable with the highest reading. Then we are also taking that bright light reading and using the step count to check where it is. Then we are calling the function so that it goes the opposite direction and in the correct number of steps. That's why you're multiplying by 6. And then we have a delay, and then we are calling it back home. And then here we are printing out the max angle and the value for the photoresistor. And here in my serial print, we can see the 3 trials of when the button is pressed, and then the max angle, and then the value for the photoresistor.